Let's talk about transformations of function graphs. So before we do that, what is the definition of a transformation? Well, transformation, this is a change to a graph based on some various parameters, and we're going to take a look at each of these different parameters in a little bit. These can include translations, stretching or compressing, or reflections of the graph. So translations, let's start there. This is shifting the function around. So the graph itself looks pretty much identical to whatever parent function you're working with, but here we can move that entire graph up, down, left, and right, but it's not going to stretch, or it's not going to compress, it's not going to move around and go in rotations or reflections in any sort of way like that. So it's as if we're taking the graph, we're picking it up, and then we're setting it back down, maybe in a different spot. So to move it up or down, what I do is I take that f of x and I add or subtract a value of k at the end. If I add, I go up. If I subtract, I go down. Whereas to move left and right, this is a little bit trickier. I'm going to add or subtract a value of h to x, except it's kind of going to be the opposite of what I would expect. If I add x plus h, then it's actually going to move to the left. Whereas if I go x minus h, it's going to move to the right. So adding moves left, whereas normally you would think adding to x is going to go to the right because we're moving more positive, but that's not actually what happens. And then we would think that subtracting from x, well, subtracting, I think of that as kind of negative. I'd go to the left, but again, it's kind of the opposite of what you'd expect. What about stretching and compressing then? Okay, let's take a look at what happens if I just multiply by something to all of f of x right at the front there. If I've got a times f of x, then the function is going to stretch vertically by whatever that factor is. If I make a 2, it's going to double the height. If I do 1 over a, it's going to compress the function vertically by a factor of 1 over a. So if I do 1 over 2 times f of x, then that makes sense that it would go to 1/2 the height of what f of x was. Then to do horizontally, okay, to compress or stretch there, I would have to multiply to the x now, not f of x, but to what's inside the parentheses right here. If I multiply by b, I would expect it to stretch, much like I did multiplying by a at the front there, but it actually compresses the function horizontally by a factor of 1 over b. So if I do f of 3x, 3 times x, my brain expects it to stretch horizontally by a factor of 3, but it actually compresses to 1/3 of the width. So everything gets shoved in 1/3 to 1/3 of what it was. And then if I do 1 over b, here, this actually stretches it. So if I do multiply x by 1 over 5, f of 1/5 x, then this actually stretches things horizontally by a factor of 5. So again, that vertical piece kind of making sense to us, but horizontally, it's almost as if it's the opposite of what I would expect. For reflections, if you multiply by a negative at the beginning of your function, negative f of x, this is going to reflect the function vertically. If you do f of negative x, this is going to reflect the function horizontally. So, quick notes here. All vertical changes happen outside of the parentheses. All horizontal changes happen on the inside of the parentheses, and that vertical changes are kind of what you would think of, intuitively. You kind of expect what would happen, but horizontal changes, it's kind of the opposite of what you would expect. So let's play around with this. Here's Desmos. I just put in a random kind of function here. I've got f of x equals 3x to the third minus 2x, and here's the graph of that. So I'm going to use this as kind of my base function, if you will. And then here, I'm going to take f of x, And you'll see that it's exactly the same, right? F of x equals 3x to the third minus 2x. Here, my second line just says f of x. It is acting as if it is that first line. Now, what happens here when I add, say, 2? We'll see that my new green graph here took everything and just shifted it up 2. If I subtract 1, you'll see that it moves it down 1. If I add or subtract to the x, so plus, say, 1, it moved it to the left 1. Here, let me turn this one off so it's a little bit easier to see. So there it is on, there off. Okay, and whereas if I subtract 1, oops, right here, that moves it to the right. So again, I'll turn this off so we can see it a little bit easier. Turn it back on. The green one is basically the red one moved over to the right. And I can actually combine these, right? So if I go minus 1 on the inside and then plus, let's see, plus 1 there as well. We're going to go to the right one, and then we're going to go up 1. So there's the new graph. There's where it was. Let's play around with the stretching and compressing. So if I do times 2, now we see here the zeros stayed where they were, but all of the other points here got stretched to double what they were originally. So if we look at, say, this point, this was about negative 0.5 roughly, and then 0.6, but then on the green, that x value stays the same, but the y value doubles. Okay, same thing here. It doubled. So if I went to 3, we would see that it's 3 times where it was. Like so. And if I don't make this a whole number, say 3, let's say I do this as 1/2, we'll see that now it's half of where it originally was. So multiplying by a number at the front, if it's an integer 3, then it's going to multiply and triple, okay, the height. But if I do 1/2, then it only goes to 1/2. That kind of makes sense. That's that vertical piece being intuitive. But horizontal changes. If I multiply by 2 here on the inside, f of 2x, my brain would expect this to take everything here and stretch it out. But actually, it compresses it in. So now if we look at the x values, what was at negative 0.8160, that was my 0 before, now becomes half of that. So this takes all of the points and it compresses them inward horizontally. And if I do a fraction, say 1/4, all of a sudden now everything gets stretched out to 4 times where it originally was. So it's very strange. It's the opposite of what you might expect to happen there. And then lastly, if I multiply by a negative here at the front, we'll see that everything just kind of reflected vertically. And if I multiply here, it looks pretty similar, but what ends up happening is it multiplies the x by a negative here and then reflects horizontally. So there is that. Let's go back to the notes here. And the last thing to talk about are odd and even functions. If f of negative x equals the same thing as if you were to plug in just f of just x, plug in x or negative x, and you get the same thing, the function is even. If we plug in negative x and it equals negative f of x, or in other words, instead of plugging in x, I plug in negative x and I get the opposite of what plugging in x would give me, then it's odd. Graphically, that means that even functions reflect about the y-axis, so they look something like this. Odd functions reflect diagonally about the origin. And if they're neither even nor odd, okay, then it's neither. It's neither. Okay. Note here, it can reflect about the x-axis, and that itself doesn't mean anything. It's not even or odd.